So wake up. This is the easiest chapter that you guys will learn. You're going to learn definitions, theories, and just the basic principle of statistics. Statistics is the science of collecting, describing, analyzing, and interpreting data. For example, say you wanted to know how poverty and criminal activity are related. You would further your understanding of this phenomena by using the scientific method to create research studies that will provide you with quantitative data, and then you would use various statistical methods to analyze the data and draw conclusions. Mathematical statistics is the study of how to create the statistical methods using mathematical principles. We will not be focusing on that during these lessons, thank God. Applied statistics is pretty much what we're going to be doing later on chapters. This is the practice of developing knowledge by using statistics methods to analyze data and make inferences about the population that the data came from.
Statistics are mathematical tools used to organize, summarize, and manipulate data.
This is an example of manipulation. Incidence over population. So you take the incidence, you divide by the population, and then you multiply 100,000, that's your answer. The top denominator includes everyone. If you represent it as the people who are most likely to be victimized, it will increase. So the bottom one, 400,000 people, it should be 400,000 women in Vancouver. You can see that the answer increases because we manipulated the denominator. So here's another fictitious example. So the point that I'm trying to get across here is what you put in the denominator should make sense with what you're studying. So a variable is a phenomenon of interest that can take on different values and can be measured. I'm going to give you an example and you see if you can identify what the variable is. Number of joints smoked per day. What's the variable in that? The variable is the joints smoked. Another one, number of hours spent studying per week. The variable in that is hours spent studying. I just want you to keep in mind that there could be more than one variable. For example, if you're asked, do people who own an iPad Touch also own an iPad? There are two variables in that, iPad Touch ownership and iPad ownership. Another one, is there a difference between males and females in the number of cigarettes they smoke per day? The two variables in that are gender and cigarette smoke per day. So an attribute is qualities or quantities that describe the variable. For example, in a qualitative variable, an attribute would be gender, and a quantitative variable, the attribute would be crime rate. So a dependent variable is a variable that changes as a result of the change in an independent variable, whereas an independent variable is a variable that is hypothesized to influence the dependent variable. This is a review. from the course you took before getting to this one, so I won't really get much into detail about that since you already understand it. So population is the total number of individuals of your interest in study. It could be people, something else, number of atoms, etc., etc. What constitutes the sample? Well, we take a subset of the population. We need a sample instead of accessing the entire population because really it's kind of unrealistic. You can't really get the entire population. We just take a sample. We can ensure that it's accurate. We don't need to get everyone. Just get enough to represent, what you're studying. Descriptive statistics explains how frequently something of interest occurs in the observations you have made. Univariate data refers to data where we're only observing one aspect of something at a time, and it has a single variable. An example would be, let's say we take a group of people, measure their heights, and then get a list of their heights. This is an example of univariate data, since we're only observing one aspect, which is height, of each person. Bivariate means two variables. This one describes the strength and direction of the relationship between two variables. An example would be male offenders, commit more violent crimes than female offenders. What are the two variables being described? Crime and gender. Another one below I have weight and donuts eaten per day, so donuts and weight.
Inferential statistics. It's used to help generalize the results found in a sample to the entire population. Allows researchers to make conclusions about population from only a subset of persons slash observation. Thank goodness for that.
Nominal is something categorical, like school or type of car you drive or name of a book. This one is easy to remember because nominal sounds like name. They have the same Latin root. Ordinal data refers to quantities that have a natural ordering. For example, a Likert scale rating from 1 to 5, or rankings of favorite sport, like for hockey, for example, I put Colorado Avalanche on top and then whatever descends down from that. Um, this one's also an easy one to remember because it sounds like order. Interval scales are numeric scales in which we not only know the order but also know the exact differences between the values. An example would be Celsius temperature because the difference between each value is the same. For example, the difference between 60 and 50 degrees is a measurable 10 degrees, as is the difference between 80 and 70 degrees. Time is another good example, I think, of an interval because all the increments are known, consistent, and measurable. Interval means space in between, which is the important thing to remember. Interval scales not only tells us about order, but also about the value between each item. To help you memorize this on an exam or just retain this information, just think of like when you go to the gym and the interval settings of a Stepmaster or treadmill. You know the times it will give you, like you'll walk for 5 minutes, then run for 5 minutes, and then so forth. Just think of that when you think of intervals. And remember, when you're running that treadmill or the Stepmaster, that interval setting is not going to stop at 0. In other words, there's no true 0 value in an interval. The ratio scale of measurement is the most informative scale. It is an interval scale with the additional property that its 0 position indicates the absence of quantity being measured. An example would be money. Let's say you have 25 cents in your pocket right now. Money is measured on a ratio scale because, in addition to having the properties of an interval scale, it has a true 0 point. If you have 0 money, this implies the absence of money. Since money has a true 0 point, it makes sense to say that someone with 50 cents has twice as much money as someone with 25 cents, or that Bill Gates has 1,000,000 times more money than you. So for categorical, values or observations that can be sorted into groups or categories. Some examples are sex, eye color, and favorite color. You have to use bar charts or pie graphs for this. Then we have numerical. Those are values or observations that can be measured, and these numbers can be placed in ascending or descending order. Some examples are height, weight, and you have to use scatter plots and line graphs for numerical data.